already discussed 8 examples of basic counting. Let's discuss example 9. What is the value of k after the following code where n1, n2, nm are positive integers has been executed? Initially, k value equals to 0. For I1 equals to 1 to n1, k equals to k plus 1. So each time k value is incremented by 1. Initially, k equals to 0. Then for I equals to 1, k will be 0 plus 1, it's 1. Then for I equals to 2, k will be 1 plus 1, it's 2. Then for I equals to 3, k equals to 2 plus 1, it's 3. Like this, for I equals to n1, k value will be n1 minus 1 plus 1, it's n1. So after this loop, k value equals to n1. Next, for I2 equals to 1 to n2, k value equals to k plus 1. So initially k value equals to n1. For I2 equals to 1, k value will be n1 plus 1. Then for I equals to 2, it will be n1 plus 1 plus 1. So it will be n1 plus 2. Like this, for I equals to n2, it will be n1 plus n2. So after second for loop, k value equals to n1 plus n2. Like this it will continue. Finally, for im equals to 1 to nm, k equals to k plus 1. So after this loop, k value equals to n1 plus n2 plus n3 till nm. Okay. So for each for loop, k value is incremented by 1. After first for loop, k value equals to n1. After second for loop, k value equals to n1 plus 2. Like this, after im for loop, k value equals to n1 plus n2 plus n3 till nm. So this is a sequence of for loop. Total number of time it executed equals to each for loop execution addition. So first for loop executed n1 time, second for loop executed n2 time, and last for loop executed nm time. Total number of time it executed equals to n1 plus n2 till nm. Next we will see another similar type of example. Example 10. What is the value of k after the following code where n1, n2 till nm are positive integers has been executed? Initially k value equals to 0. For I1 equals to 1 to n1. Then for I2 equals to 1 to n2. This is a nested loop. Like this, for im equals to 1 to nm, k equals to k plus 1. For I1 equals to 1. Then for I2 equals to 1, then it will completely execute the inner loop, means this for im equals to 1 to nm. So first it will be nm, then its previous for loop, let it be nm minus 1, n2, n1. So total number of time it will execute equals to multiplication of all these, as it is a nested for loop. So each time nested loop is traversed, 1 is added to k. By the product rule, it follows that nested loop is traversed n1 multiplication n2 multiplication till nm time. So final value of k is n1 multiplication n2 till nm. So that's the difference between nested loop and normal sequence of for loop. In case of nested loop, total number of execution is the multiplication of all loop, whereas in case of this type of a sequence for loop, total number of execution is addition of each for loop execution time. In case of nested for loop, we are using the product rule, whereas in case of sequence for loop, we are using the sum rule. Next, example 11. 4 distinct dice were tossed. Number of outcome in which at least one dice so 2 equals to. So number of outcome possible with 4 dice equals to 6 power 4, as each dice have 6 faces, right? So each dice have 6 faces and we have 4 dice. So total number of outcome equals to 6 power 4. When we are skipping 2, there are 5 faces. So it will be 5 power 4. So total number of possibility that at least one dice so 2 equals to 6 power 4 minus 5 power 4. It's 671. So 671 is the possible outcome that at least one dice so 2. Next, example 12. How many 4-digit integers are there with digit 6 appear exactly once? There are 2 cases. In first cases, consider 6 at the first places. So you have 4 digit 1, 2, 3, 4. First digit contains 6, then second, third and fourth can be 0 to 5, then 7 to 9. So for first place there are 1 possibility, for second place there are 9 possibility. Total there are 10 digit, but as we are excluding 6. Okay, so 6 should be appear exactly once. Then in third places there are 9 possibility, again same 0 to 5, 7 to 9. Then in fourth place there are 9 possibility, 0 to 5, 7 to 9. We are excluding 6. So this is one way. How many numbers possible? 9 multiplication 9 multiplication 9. Then case 2, if 6 appear in the second, third or fourth. 6 appear here, so there is 1 possibility. Here 0 to 5, 7 to 9, 9 possibility. Here 0 to 5, 7 to 9, so 9 possibility. But in first place there cannot be 0. If there will be 0, then it will be 3 digits. So it is asking number of 4 digits. So in first place it can be 1 to 5, 7 to 9. So there are 8 possibility. So how many number possible with 6 present at second place is 8 multiplication 9 multiplication 9. If 6 place at third place, so here is 6, and in first place it can be 1 to 5, 7 to 9, so 8 possibility. For second 0 to 5, 7 to 9, 9 possibility. For fourth 0 to 5, 7 to 9, there are 9 possibility. So here also 8 multiplied 9 multiplied 9. Then when 6 appear at the last place, okay, 6 appear here, so there is 1 possibility. Here 0 to 5, 7 to 9, 9 possibility. Second place 0 to 5, 7 to 9, 9 possibility. In first 1 to 5, 7 to 9, so 8 possibility. So total number of way 6 can appear exactly once equals to 9 multiplied 9 multiplied 9 plus 3 times 8 multiplied 9 multiplied 9. So here this result is 2763. So total 2763 4-digit integers possible, having 6 appear exactly once. So there are two cases. First cases 6 appear at first places. Then in second cases 6 can appear at second, third or fourth places. So if 6 appear at first places, there are 9 multiplied 9 multiplied 9 way. Then if 6 appear at second, third or fourth, there are 8 multiplication 9 multiplication 9 in 3 way. So total number of 4-digit integer with 6 appearing exactly once equals to 2673. I discussed total 12 examples of product rule and sum rule. In next lecture, I will discuss permutation. If this lecture is helpful for you, please like, share and subscribe. Thank you.